Okay, hello my friends. In this video I'm gonna solve these two, I think, really very easy equations called irrational equations, uh, and yeah, I think these equations are really like very easy to solve because the procedure is really simple. The only thing you have to do is to isolate the radical on one side so that it stands there like alone, and then you simply uh, do square both sides of the equation, and you eliminate uh, radicals like step by step, one by one. So let's have a look on this first one, which is really like simple, though it doesn't look simple because maybe you are afraid of this expression, which is quadratic expression x squared under the square root, but as you will see during our solution that this is really something simple. So as we have radicand on the left side like isolated, it's clever idea to square both sides of the equation, and I will simply write this again so that you really realize why the next step is like it is. So basically it means you square left side and you square the whole right side of the equation, which is something like this. That's why it would lead us, after applying this square for both sides of the equation. Let me delete, and now just have a look what will happen. As we already know, the square of squaring the square root will lead to expression which is under the square root. So basically the left side will become something like this, and what the right side is gonna be, yes, it's one of our favorite formulas, so it will be x squared take away 2x plus 1, because this is really like well-known formula. So what are we supposed to do now? We move the whole expression from the right side to the left side. So basically it means we do in one step take away x squared plus 2x take away 1. So our equation will be now like take minus 2x squared plus 6x, and then minus 1. This is really gonna be, now I see, very simple, because we have already very simple quadratic equation. I will just multiply it by negative 1, so that I have really, or I can multiply not by negative 1 but by negative 1 over 2. And now the equation will be x squared plus, take away 3x equals 0, and this equation is really easy to solve because we can factorize it like x times x minus 3 equals 0, and as we already know, this equation has two solutions. The first one is x equals 0 and the second one is x equals 3. As we already know, it's very important to do the check, because we used something which is not like equivalent operation. So let's do the check for left side, for x being 0, which means this is like square root 1 plus 0 take away 0, so this is square root of 1, which is 1. Nice, and have a look what is the value of the right side of the equation for 0, and it would be 0 take away 1, which is negative 1. So it means our left side is not equal to the right side, so x equals 0 is not our solution of the equation. Let's have a look what is going to happen with the left side for x being 3. So this is gonna be square root of 1 plus 4 times 3, take away 3 squared, and it equals square root of 1 plus 12 is 13, take away 9, which is square root of 4, and this is 2, nice number. And let's have a look what will we get for the right side, for x being 3. So this is gonna be 3, take away 1, which is true. So it means our left side now is equal to the right side, which means the solution of our equation is the set of roots but basically it's only one root, so the only solution is number 3, because the check was correct only for number 3. If you really want to find out why, there is a good manner sometimes, but this is just, I want to remind you that the thing is that our square root of this expression is defined only if the expression under the radical is greater or equal 0. So basically it would mean, to solve the inequality, 1 plus 4x take away x squared must be greater or equal to 0. Okay? As you can see, is it possible to do something like no, I'm quite lazy, so I will use the discriminant. So this is b squared take away ac. In our case, the discriminant is equal to 16 minus 4 times, be careful, a is -1 times c is 1. So our discriminant will be, oh, it looks like it's not gonna be very nice number, but it's yeah, okay, so it's 12, because no, it's not 12, oh no, I'm sorry. It is 16 plus 4, which is 20. Okay, so our x1 x2 roots will be then take away b plus minus square root of discriminant over 2a, which will lead us to -4 plus square root of 20 over 2a, so it's -2 because a is -1, and the second root would be -4 minus square root of 20 over -2, and this is approximately but as you can see, I'm pretty sure you can see right now, -4 over -2 is 2, okay, minus square root of 20 over 2, and square root of 20, let me use the calculator because this is really something I wasn't expecting. It's 4.48, so 2 minus 4.4 is minus 2.4 approximately, and this number is gonna be 2, and in this case it's gonna be plus square root of 20 over 2, which is approximately which is of course positive number, and I'm not gonna calculate. So as you can see, our parabola would look like something like this, and it means 0 is not included because this part of parabola is under the x-axis. That's why these roots or x's are not included in the domain of our given function. That's why 0, as you can see from our check, is not valid root for our equation. Okay, but the main goal was to solve this equation, and as I said, it's really important when you solve irrational equation to do the check above all the solutions you get when you are solving the equation. So This one was really like very easy. Let's have a look to this one, which looks a little bit more complex, but again, as I said during our lessons, there's nothing special about this equation. The only thing that will happen now, you will square both sides like 2 times. So as you can see, and it's really okay, we have one of the square roots like isolated, so we can now simply square both sides of the equation. Again, the same thing as I did before, we square both or sides, like the whole sides. We don't square the left side like one squared, second one squared, and the roots are gone. No, it's really important to realize that this operation applies for the whole expression on the left and on the right side. So if we apply this one, we already know that this is again our super special, tricky, very often used formula. A plus b squared equals blah blah blah. So it will become x plus 2 times square root of x times x take away up square root of x take away 3 plus x minus 3 equals, this one is simple, 3 times x minus 1. Okay. As we can see, and we have to simplify the expression on the left side of the equation, so it will be 2x minus 3 plus 2 times, and we can put this under the 1 square root. We already know the formulas y, so it's gonna be x squared, because x times x is x squared, minus 3x equals, and I will rewrite this one as 3x, I will factor, multiply, and minus 3. Now, as we said, we really need our square root like being alone on any of the sides of the equation. So we will do this operation, take away 2x plus 3, so that we will get rid of this expression on the left side of the equation, and then we will get 2 times square root of x squared minus 3x equals x. Oh, that's good, that's nice, because these 3's are again gone. As we have our expression only one square root here, we can again apply square of both sides. So it will be 4 times x squared, take away 3x equals x squared. Okay. Very nice. I can see that I really have chosen simple equations, but you never know before you try to solve. So 4x squared minus 12x equals x squared. Take away x squared is my operation, so 3x squared minus 12x equals 0. Again, I can simplify by multiplying 1 over 3, which will cancel number 3 here, and the negative 12 will become like negative, x squared, like negative 4x equals 0. And we have again very simple quadratic formula, which can, okay, I will write it, be written as x times x minus 4 equals 0, and as you can see, x must be 0 because multiplication equals 0 only if one of the factors are 0, so x is 0 or x is equal to 4. Again, as this is not like equivalent operation, you have to do the check, and let me do it here. So check of the left side for 0 is square root of 0 plus square root of x minus 3, oh sorry, not x but 0 minus 3. And as you already said during our lessons, and you probably noticed that this is gonna be negative number, and the square root of negative number is not defined. So basically from this means that that our root cannot be 0, so we have to exclude this one from the set of the roots. and we can simply skip the rest of the check for x being 0, and we can do the check for x being 4. So the left side for number 4 is equal square root of 4 plus square root of 4 minus 3, which is, I am pretty sure you can see, 2 plus 1, it equals 3, and the right side for number 4 is square root of 3 times 4 minus 1, which is square root of 9, and this is really number 3. So we are done here, and we just do the conclusion that the set of the roots for our given irrational equation is just one element set, and it is Hobbes number 4. Okay, so this is basically it. Thanks for watching, and see you during our next video.